morning, students. Chapter 7, System of Particles and Rotational Motion. In last lecture we have discussed about two most important theorem about moment of inertia and two questions for particles. Okay, how to find moment of inertia about given axis. Yes, for particles we know equation. Okay, here I am writing for particle. We know what is equation of moment of inertia. Particle means small size. Moment of inertia I is equal to it is mr square. M is mass of particle and r is distance from given axis. So yes, for particle I can use this equation. But what is moment of inertia if you are given object, a body, okay, rigid body of different shapes? Then how to find moment of inertia? We will see one case today. Yes, title is moment of inertia of a thin rod about an axis passing from its center and perpendicular to its length. See here, in question of moment of inertia, axis is important. See, object is a thin rod. Okay, so first of all, we will assume one thin rod like this. See, here it is. First of all, we will assume one thin rod like this. Suppose it is thin rod. Okay, so yes, it is given one thin rod. Let its total length is L and its total mass is M, having uniform density. So yes, I am writing. Okay, let mass of thin rod having uniform density is M and its total length is L. Yes, its total length is L. So see, first of all, from this mass and length, see, thin rod we can consider as one-dimensional object. Thin rod we can consider as one-dimensional object. So for thin rod, I will find linear mass density. Okay, it's linear mass density. Lambda is equal to total mass upon length. Clear about this? Total mass upon length. Okay. Now, yes, it is clear. Now, about which axis you have to find moment of inertia? See, moment of inertia of thin rod about an axis passing from its center. Yes, it is its center. Okay, so moment of inertia about an axis passing from center and perpendicular to its length. It is its length. So only one axis is there which is perpendicular to its length. So about this axis you have to find its moment of inertia. Clear about this? Okay, again, passing from its center and perpendicular to its length. So about this axis you have to find its moment of inertia. Now for moment of inertia we know only equation of particle. Then for this thin rod, how to find moment of inertia? Yes, see, we can assume that this thin rod is made up of very small elements. Yes, very small elements. Okay, one element I am taking here. Suppose it is very small element. Okay, it is very small element. Very small element means I can consider this element as a particle. Yes, as it is very small, I can consider this particle. I can consider this element as particle. Clear? So yes, here I can assume this rod, it is made up of very small elements. Very small elements. Okay, first element, second, third, fourth, 5, dash elements. Okay, for simplicity I will indicate only one element. Okay, having length dx at distance x from given axis. Clear about this data? Clear about this data? Okay, assume one element having length dx at distance x from axis. Okay, so yes, divide rod in very small elements and take one element. Okay, so as shown in figure, length of element is dx at distance x from axis. Clear about this? At a distance x from axis. So yes, I can consider this element as particle. I know distance. First of all, I have to find what is mass of element. So how to find mass of element? See, mass of element. M is equal to mass of element. M is equal to small m. Mass of element small m is equal to, it is lambda dx. How? Remember? Okay, what is lambda? Lambda is mass per unit length. Means if length is unit, mass is lambda. So for length dx, what is mass? So yes, dm is equal to, it is lambda dx. So yes, you have to remember this point. So mass of element is m is equal to lambda dx. What is value of lambda? It is m upon L dx. Clear? So now we know mass of this element. What is perpendicular distance from axis? It is x. So we will find moment of inertia of this element. Moment of inertia of element about given axis. Di is equal to, why I am writing di? Moment of inertia of element is very small. So whenever you find quantity for any small element, any small particle, you have to write d. Okay, moment of inertia, so it is di. If you find mass, then yes, you can write dm. If you find electric field, then yes, you can write de, etc, etc, etc. If you find force, then yes, you have to write df. Okay, so as it is moment of inertia of element above given axis, so di is equal to, what is equation? It is mass of element is m. What is perpendicular distance of element from axis? It is x. So it is m x square. So put value of m. That is, it is m upon L x square, and here, m upon L dx, and here it is x square. So I can rearrange this as di is equal to, it is m upon L x square dx. But see, it is moment of inertia of this element only. We have to find moment of inertia for the whole object. See, divide rod in very small elements. It is only one element. Similar thing you have to find for another element, for next element, for next element, for next element, for next element, and to find total moment of inertia, you have to take their addition. And yes, as elements are very small, that addition converts in integration. So now how to write total momentum of total moment of inertia, of thin rod about given axis, about given axis. It is I is equal to integration di. It is I is equal to integration di. See, it is method, dear students. Hello. You are given one object. You have to find moment of inertia. But you have equation of particle only. Then how to find moment of inertia of this object? Divide this object in very, very small elements. Take only one element and find moment of inertia for one element only. And to find total moment of inertia, you have to take integration. You have to take integration. Integration means addition, summation. Clear? So it is method that you have to remember. It is method that you have to remember. Clear about this? Okay. Now I is equal to integration di. So I is equal to integration di. See here, integration di means here it is m upon L x square. Here it is dx. Clear about this? Capital M, mass of rod, constant. Total length, constant. So is equal to, it is m upon L integration x square dx. So see, here integration is with respect to x. Now what is x? See, here it is. X is distance of this element from this rod. Yes, this total length is L. This total length is L. If I am taking this center at origin, okay, then it becomes positive x-axis and it becomes negative x-axis. Total length of rod is L. So yes, this length will be L by 2. This length it will be also L by 2. If I write coordinates, then their coordinates are, here it is called plus L by 2 and here it is called minus L by 2. Why minus L by 2? Because it is on negative axis. Because it is on negative axis. So see, x means what? X means distance of this element from axis. All elements, see, all elements are between these two ends. Element, see, these all elements are between these two ends, okay. So it indicates limit of integration, okay. You have to take addition between minus L by 2 to plus L by 2. You have to take integration from minus L by 2 to plus L by 2. So yes, here you have to write limit minus L by 2 to plus L by 2. Clear about this? Simple. Limit means what? Limit means it is the range in which elements are there. Okay. Okay, here each and every element they are between these 2 points. So it is lower limit and upper limit. Okay, now integration, you know that x square dx. So increase one power and you have to write that power in denominator. So is equal to, it is m upon L x cube by 3. Limit is from minus L by 2 to plus L by 2. Simple. I can write this 3 outside bracket. So it is m upon 3L in bracket x cube minus L by 2 to plus L by 2. Now put value m 3L. First of all, write upper limit. Instead of this x, you have to write L by 2. So it is x is replaced by L by 2. So it is L cube divided by what is cube of 2? It is k. In between there is always negative sign. Now x is replaced by minus L by 2, and as it is odd power, answer will be negative. Means it is minus L cube by. Any doubt? Any doubt? Okay. Again, upper limit minus lower limit. So now is equal to, it is m upon 3L. Minus minus will become plus. So I can write directly it is 2L cube by k. Okay, so 1 L cut, here it will be 2 power, it is 2, it is 4. So yes, is equal to, it is m L square, divided by 3 into 4, that is 12. So moment of inertia I is equal to, it is ml square by 12. Moment of inertia I is equal to, it is ml square by 12. Clear about this? So yes, it is one equation. Okay, if you are given a thin rod of mass m, length L, then what is moment of inertia about an axis passing from its center and perpendicular to its length? I is equal to ml square by 12. I is equal to ml square by 12. Clear about this? Again, repeating theory. You are given one thin rod. Its mass is given, its length is given. Find linear mass density because it is linear object. We have to find moment of inertia about this axis, but we know equation for particle only. Then how to find? Assume that this object is made up of very small elements. We can consider small elements as particle. So yes, out of all small particles, take only one particle, assume its length, distance, find its mass, find its moment of inertia. Then to find moment of inertia for the whole object, you have to take its integration. Steps of integration. Moment of inertia I is equal to it is ml square by 12. Moment of inertia I is equal to it is ml square by 12. Clear about this? And see again, hello. This axis is passing from its center. This axis is passing from its center. So I can say yes, it is IC. I can say it is IC. That is moment of inertia about an axis passing from its center of mass. Okay. One more last step. See, here it is. Here it is. I can compare this equation I is equal to with I is equal to mk square. So see, I is equal to mn. So what is comparison? Yes, k square is equal to L square by 12. So k is equal to L upon root 12. And root 12 means 4 into 3. And what is square root of 4? It is 2. So k is equal to it is L upon root 3. So it is its radius of gyration. It is its radius of gyration. Clear about this? Okay. So yes, it is one theory. It is one theory. Okay, how to find moment of inertia of a thin rod about an axis passing from its center and perpendicular to its length. It is the whole theory. Okay, how to calculate moment of inertia. Clear about this? Again, it is important question. How to solve such questions? Okay, repeat and repeat this method. You can easily understand. Okay. Next theory, see, moment of inertia of thin rod about axis perpendicular to length and passing from one of the end. See, again, it is thin rod. Yes or no? Yes. Its mass is m. Yes, thin rod. Yes, it is thin rod. Okay, its mass is m, its length is l. Okay, you have to find moment of inertia perpendicular to length and passing from one of the end. I am taking this end. So yes, about this axis you have to find its moment of inertia. About this axis you have to find moment of inertia. I am assuming here this axis is a dash. Okay, so let a dash is axis perpendicular to its length and passing from one of the end. Okay, now how to find moment of inertia for this axis? Yes, you can find with the help of method that we have discussed in previous theory. Okay, but it will be lengthy. Okay, what is use of parallel axis theory? See, it is axis passing from end. If I am taking this axis, it is its center. I am taking this axis. Then see, this axis is parallel to this axis. Yes, it is axis passing from center and perpendicular to its length that we have discussed. And we know moment of inertia about this axis, that is IC is equal to, it is ml square by 12. And now we have to find moment of inertia for this axis. As these two axes are parallel, you can use parallel axis theorem. So yes, see, from parallel axis theorem, from parallel axis theorem, okay, IAA dash means moment of inertia about an axis perpendicular to length and passing from one of the end is equal to, what is equation? IC plus md square. IC plus md square. Remember equation of parallel axis theorem. I is equal to IC plus md square. IC, we know what is moment of inertia from this axis. It is ml square by 12 plus mass of object is m. What is d? D is distance between two. D is distance between two parallel axes. Yes, distance between these two parallel axes is nothing but L by 2. Yes, it is L by 2. So D is replaced by L by 2 also. Clear about this? So it is ml square, okay, is equal to, it is ml square by 12 plus, here it is ml square by 2 square, it will be 4. Simple? Simple is equal to, now I can write ml square by 12 plus ml square by 12, so it is 3 ml square. Simple? And it out, so is equal to, it is 4 ml square by 12 is equal to ml square by 3. I dash. Moment of inertia about an axis passing from its one of the end and perpendicular to its length. I dash is equal to ml square by 3. Simple? See, with the help of parallel axis theorem, what is length of question? What is length of question? Clear about this? Now, how to find radius of gyration? See, IA dash is equal to ml square by 3. Compare this equation with I is equal to mt square. It is simple. I is equal to m. So t square is equal to L square by 3. So therefore K is equal to L upon root 3. It is radius of gyration. It is radius of gyration. Simple. So see, for a given object, for one given object, that is thin rod, if you select different axes, moment of inertia is also different. So yes, moment of inertia depends on selection of axis. If you change axis, moment of inertia also differs. Clear about this? So yes, it is one case, that is thin rod. For thin rod, what is moment of inertia? We have discussed two equations. Clear? And it out? Okay, revise this video 1 or 2 times, and till that, if you have any doubt, contact me. But for today, this is it from my side.